Different test methods are used to quantify gel time based primarily on the speed that your application needs. The first test is ASTM D3056, also known as the sunshine gel meter test. This is a diagram of a sunshine gel meter. This instrument works by submersing a glass rod into the mixed material and slowly turning the glass rod. When the material reacts to the point where the glass rod can no longer rotate, the upper electrodes touch and sounds an alarm. This method is primarily used for urethane systems that react very quickly for a fast transition to an elastomer. Typically, this is for systems with a gel time of 20 minutes or less. The second method is used for systems with a slower transition from a liquid to an elastomer. This method utilizes ASTM D2196, which measures viscosity in centipoise as the polymerization reaction proceeds. Ultimately, this test monitors the viscous nature as the polymerization reaction transitions the material from a liquid to an elastomer. In most cases, gel time is defined by a terminal viscosity that is prescribed based on the application where the material is being used. Typically, this method is used for systems with a gel time of 20 to 40 minutes. The third method uses a rheometer to determine when the elastic properties of the polymer dominate. A rheometer is an instrument that simultaneously measures both the flow and deformation of materials. During the curing process of a urethane polymer, these fluid and elastic properties are dynamic, making a rheometer key to the characterization of the curing polymer. More specifically, we look to analyze two properties as the thermoset cures: the storage modulus and loss modulus. The loss modulus is a measure of the fluid properties of the material versus the storage modulus is a measure of the elastic properties of the material. In this graph, you will see the quantitative analysis of the loss and storage modulus of a curing thermoset. As the two-component thermoset begins to react, you can see that both the loss and storage modulus increase. They will both continue to increase until they reach what we call the crossover point. At this point, the elastic properties overtake the fluid properties. We relate this to the no flow point in the reaction, which is analogous to the gel time. Additionally, the rheometer can precisely measure this crossover point at any temperature between -40 C and 100 C. This type of analysis gives your process engineer vital data for manufacturing improvements and optimization.